Hi, welcome again. We're going to go over the next two assignments today on iExcel. Really, these problems here are just to give you an opportunity to practice. We're spending a lot more time than we normally would. These usually would be done in like 2 lessons. We're taking like 4 lessons instead. So make sure you're taking advantage of the extra time to make sure you learn the material. This material will once again be used next year in Algebra 2, in pre-calc and calculus. I can't stress how much we use square roots in calculus. And of course, it's a given. If we're using a lot in calculus, we're using it in geometry, algebra 2, and pre-calc also. Also, these will also appear in the SAT. Eventually, when the world ends, or when it doesn't end, when we restart. So we're going to work on adding and subtracting radical expressions. I'll be posting this homework example up later, or the homework up later. So we're going to work these problems together. And if you have any questions, go ahead and type in the chat below. That was the other class. Okay, the problem says, hey, can I add two radicals? Can I add -7 square root of 3 plus 4 square root of 3? Like, are these even the same type of animal? Oh my gosh, Josh. See you later, Josh. Sorry, reading the chat is not a good thing. So we're going to add, the question is when I'm adding numbers, are these like terms? Now let's go back and rewrite this. If I wrote this as a -7x plus 4x, -7x plus 4x. Could I do this? Well, if I combine them, well, they are like terms. They both have 1x. So if I have -7 plus 4 is -3x. The same thing happens here, where x can be square root of 3. So since they have the same square root of 3 here, we can call them like terms. So you could say, if we want to use words, we say I have -7, call those dogs, right? -7 dogs plus 4 dogs. Well, they cancel out, leaving me -3 dogs. Okay, and it's very similar to what we have for x's. So it's not really new, and it follows many of the same rules, except we just have to write radicals now. Now, what if we wrote something that looks like, well, let's do one more problem. If I write 10 square root of 5 minus 2 square root of 5, or 6 square root of 11 plus 7 square root of 11. Okay? We're just saying, hey, I have 10 somethings, and minus 2 of those somethings, those same somethings. You call these oranges. I have 10 oranges minus 2 oranges. I have 10 apples minus 2 apples. I have 10 square root of 5 minus 2 square root of 5. Well, since they are like terms, they have the same exact type of counting, 8 square root of 5s. Over here, we're adding 6 square root of 11 plus 7 square root of 11. Since they're the same type of square roots, we add them to become 6 plus 7 is, you guys said it, 13. 13 square root of 11. Now, here is just a different way of seeing it. You guys remember the idea of factoring? Factoring means we're going to pull out what's in common. So what is in common between 6 squared of 11 and 7 squared of 11? Well, they both have a squared 11. So we could rewrite this to be squared 11 left over 6 plus 7. Hey, and 6 and 7, we can add those. That's 13. Square root of 11 times 13. When we multiply, 13 is on the outside, stays on the outside, and 11 is on the inside of the radical, so we keep it on the inside. So both ways work. Of course, this way is the easiest. This is the easy road. This is the easy road. Of course, this is kind of like the more complicated way over here. But both ways get us the same answer. And in math, there's always a lot of different ways to get the same place. Right? Easy road. Okay. Let's see. Is there another question? Same thing here. Just as a reminder, this is 4 square root of 14 minus square root of 14. You might be saying like, well, how do I combine those? Just as a reminder, what is invisible? What's in front of here? That's just invisible 1. Plus 4 minus 1 is 3 square root of 14 still. Now these problems, the first section, aren't going to be that hard. We're just practicing these, making sure you're good with this. Now the last section here is going to be a little tough because the numbers are not going to match. And you can only add like terms when they have the same radical. Now, I see negative 5 square root of 14 minus 3 square root of 126. And 126 here looks nothing like the 14 I have here. Well, the 126 is actually a 14 in disguise, probably. I don't know. I'm just guessing because these types of problems sometimes. So let's see if we can break down 128. Oh, 126, I'm sorry. Smallest number we divide. This is my box method. And the 6. 6 goes into 6. Now 2 goes, sorry, let's restart. 12 divided by 2. Or we could think of it as 2 goes into 12 6 times. No remainder. 2 goes into 6 3 times. Let's keep on going. 3 goes into these numbers. 3 goes into 6 2 times. 3 goes into 3 1 time. 3 goes into 21 7 times. We have a pair that gets thrown out. But guess who's waiting for you on the outside? We already have a 3 out there. To rewrite this, negative 5 square root of 14. That's 3 times the 3 that we brought out. That's this 3. This is this 3. That's a 9 minus 9 square root of. Now we still have a 2 and a 7. 2 times 7 is the 14. Now let's look at the problem over again. We go ahead and say, hey, now that I've simplified the problem, can we combine them? Are they like terms? Yeah, they're both 14 now. Negative 5 and negative 9 becomes negative 14 square root of 14. So the point is that things aren't always obviously going to be the same. And sometimes when they're not, we have to adjust it. We'll do the problem again. We'll simplify the problem. And it turns out they are something we can combine. They're like terms. Let me go write that. We'll put the negative sign. We said negative 14 radical 14. Fantastic. Thank you. Again, our next problem, we'll do that one more. 5 squared of 11 minus 2 squared of 99. Now, 11 and 99, they don't look alike. They don't look like they're like terms. How dare you say we look alike? Right? They don't look alike. So let's see. Can I break down the square root of 11? 11 times 1. That's it. So nope. On the side, let's go and draw our box method. Let's try 99. Smallest number I can divide 99 is 3. 3 goes in 9 3 times, no remainder. 3 goes in 9 3 times, no remainder. 3 goes into 33 11 times. We do have a pair. That pair gets kicked out of my square root. So we're kicking out of the square root. With 5 square root of 11. 2 and the 3 outside now become a 6. Left over 11. Hey, these are like terms now. So that's negative 1 because 5 minus 6 is negative 1 square root of 11. Let's see if we can write that negative 1. Negative 1 square root of 11. Let's see if it'll mark me correct. Sometimes the 1 will mess me up. Correct. That's right. Good job. Give myself a pat on the back. Give yourself a pat on the back. Be able to follow. If not, that's what the practice for. And if you want, you can watch this video again, hopefully. Let's do one more, okay? 7 square root of 150 minus 3 square root of 6. That doesn't look like a square root of 6, does it? So let's go ahead and do the box method. Okay, 150. Smallest number I can divide 150 is 2, 75. Smallest number is 3, because 3 goes into 75. I have 3 quarters. Oh, this is 5 and 5. 5 on the outside gets thrown out. Hey, 5 and 7 make 35 now. 35 square root of 6 minus 3 square root of 6. Do we have like terms? Yeah, they're both square root of 6. So how many squares of 6 do we have? We have 35 minus 3 is 32 squared of 6s. Okay. 32 squared of 6s. All right, wonderful. Okay. So hopefully, let's pause here for just a moment. Actually, no, if you have any questions, go ahead and type in the chat box. Anyone? Jesse, yes, you have a question? Raise your hand. Okay, we're gonna move on. Okay, gonna move on. Okay, here we go. Next problem, let's go ahead, take a look at it. Over here, with EE, I think. So our next one is gonna be dividing radical expressions. So this one is the harder of the two. So it is harder of the two. Now, let me take a look at all these different ones. All pretty much the same style. Let me check one thing out real quick. If you guys remember these problems here, let me jump to the last couple ones. Okay. Let's see. Let me check one more thing. Mixed review. Combining. Multiplying. Taking the radical. The radicals. Okay. Does the way you solve those last problems work for every problem? When it comes to adding and subtracting radicals, yes. Either they match, so we can combine them. If they don't match, we can't combine them. You're done. Don't even bother. If you could simplify the square roots like these last problems, like this one here. Square root of 72 doesn't look like a 2, but square root of 72 is really 36 times 2. When you know what the square root of 36 is 6. So in the end, it is a square root of 2. So they would have in like terms. If you don't have like terms, we're done. Okay, so let's say it was just 5 square root of 3 plus 2 square root of 4. No, not square root of 4, I'm sorry. Square root of, let's say 5. These are not like terms, so you cannot combine it. Yes, that was one of our problems over here on our last worksheet. Using multiplying radical expressions, writing them together. You can watch the video on that. I'm gonna have to delete the video soon because we had students talking that one. Make sure you watch that. As well as distributive property. The last part, I think today is just going to be, this is going to be quick, just so you give you guys some time to catch up. So simplifying radical expressions, this is just going to be a mixed review. And we just did this problem today. Are square root of 3 and square root of 3 like terms? Could I subtract them? The like terms? So negative 9 and negative 4. All right. So the answer, negative 5 and negative 4 combined become negative 9. Now a big deal is what happens to square roots? Square roots only change when you're multiplying them. If not, they're like terms. If I say on the side here, if I say 2x plus 3x, right? Sorry. This is 5x, right? We don't say 5x squared. This only happens when we're multiplying. So same thing for our square roots here. When I say for this problem, negative 5 square root of 3 minus 4 square root of 3, okay, that's negative 9. That becomes square root of 3 only. We're not multiplying it. It doesn't become 9. It stays square root of 3. If I add 5 oranges to 4 oranges, we end up with 9 oranges. We don't end up with 9 oranges squared. That'd be a weird looking orange. Next review problem. It's distributive property. We're multiplying everybody by everyone. So we're going to multiply 3 plus square root of 2, negative 9 plus square root of 3, and multiply. That becomes negative 27 in the front, and 3 times square root of 3. Since they're not both in the square root, we write them separately, one on the outside, one on the inside. Next, we do square root of 2 and square root of 2. Since they're not both in the square root, we write them separately, 9 on the outside, square root of 2 on the inside. And wait, isn't square root of 3 and square root of 2 both in square roots? Square roots always multiply square roots. That's square root of 6. And let's see, do we have any like terms? 27. Nope, because everyone else has a square root. Everyone has a date to the problem. This one's a square root of 3. Does that look like a square root of 2? Does that look like a square root of 6? Nope. No one has any similar square roots. So that's actually your answer. It's going to be kind of hard to write in. Negative 27 plus 3 square root of 3 minus 9, done it, minus 9 square root of 2 plus square root of 6. Ooh, that was correct. That was scary. Okay, same thing happens here. We're going to multiply only negative square root of 3 times 9 and square root of 2. Okay, is that a bad issue? So it becomes a positive 9 square root of 3 plus a square root of 3 and square root of 2 become a square root of 6 because they're both square roots. Now can I combine the square root of 3 and the square root of 6? Nope. So we're done. That's it. This is where we take the square root. Let me go ahead and plug this sucker in. It's going to square root of 12 over 49. Can I take a square root of 12? Can I take a square root of 49? I know what the square root of 49 is. 7. Let's break out 12. Box method. I always automatically run to it. A pair of 2s. Leftover 3s. 3s have no friends. You stay home. I mean, they're also at stay at home. Bad jokes. Okay. Same problem as before. So you guys are going to be working on these two review. One is not, and one is will be. And then I'll give you guys also a handout worksheet for tomorrow. We need to go over one more type of radical. Just make sure we got it, okay? Any questions for today? I'm going to stop recording.